If you run a plant, a cold storage facility, a hospital, a school system, a municipality, or a large commercial operation, and you open your electric bill, see a time of use or peak versus off peak section, and think, I have no idea what this is, but it looks important. This episode is for you. If you're getting pitched storage, automation, or even solar with the promise that it'll work great with your time of use rate, and you don't feel confident pushing back with specific questions, stay with me here. By the end of this episode, you'll know three things. First, what time of use actually is at a decision maker level. Second, when it clearly helps facilities like yours and when it does not. Third, the exact questions you can ask a vendor or partner to tell whether they actually know your tariff or they're just waving their hands around. I'm Daniel Burke, and you're listening to the TEG podcast. If you're a plant manager, facility manager, superintendent, COO, or energy manager who's spending far more time thinking about power than any normal person would want to because utilities and vendors keep driving up costs and complexity, well, I am talking to you. Today, we're decoding time of use rates. The core question is simple. How can your commercial or industrial operation adapt how and when it uses electricity so that under a time of use rate structure, you actually pay less instead of more? So let's set the stage. This episode is for commercial and industrial operators, manufacturers on 1, 2, or 3 shifts, cold storage facilities trying to keep product at temperature, hospitals that cannot turn things off on a whim, school systems, municipalities, large retailers. Data centers show up in this topic because they are a very large load, but my main focus here is everyone in between houses and giant steel mills and car plants, right? Not the houses, not the steel mills, but everyone in between. You are not in the energy business. You're in manufacturing, education, healthcare, public service, or commercial operations. Power is a boring, confusing, expensive burden you are forced to care about because of your budget and specific operational headaches. So my job today is to translate this one slice of the mess so you can make a clear decision. So we'll start from first principles. There are 3 basic classes of rates most listeners will run into. First, what I call power rates. These are simple usage rates. You get charged a flat cost per kilowatt hour of energy. You use more kilowatt hours over the course of the month, and your bill goes up linearly. Second, demand rates. On these, you're charged for both energy and demand. There's a cost per kilowatt hour and a cost per kilowatt of demand. That demand line is based on how high your load peaks inside the billing period. Third, time of use demand rates. These are usually demand-based rates that have extra provisions for when that demand happens. There are incentives or penalties based on whether your demand shows up in what the utility defines as a peak versus off-peak window. That last category is what most people mean when they talk about time of use for commercial and industrial customers. It is not usually just energy is cheaper at night. It's usually that the demand components of the bill are treated differently depending on when they occur. And this is why it gets tricky fast. On paper, time of use sounds straightforward. The articles will tell you during on-peak hours when the grid is under strain, prices are higher. And during off-peak hours, generally nights and weekends, prices are lower. They'll give you example windows like weekdays from early morning to late evenings being on peak and late night and weekends being off peak. In reality, those windows are not defined by the industry. They're defined by one utility at a time and sometimes one rate at a time. The exact start and end times and which days they apply to are written down in the tariff for your specific rate. And that's the first key point. Time of use, or TOU, is not a vague idea. It's a very specific set of times and days that change how one or more lines of your bill are calculated. Now, from the grid side, the stated objective makes sense. When industry ramps up during typical working periods, grid demand rises. When everyone goes home, residential load ramps up. Utilities and planners are trying to get you to use more electricity in the periods where the system has slack and less where it's already strained. So they do that with these price signals. On paper, if enough customers move demand away from crowded periods, you get less stress on the grid, fewer expensive peaker plants turning on, and a smoother load profile on their side. That's the theory, anyway. Where I part ways with most of the writing on this is how they talk about transparency and environmental benefit. You'll often see language like time of use rates provide cost transparency, as if just having three different price periods with different numbers on them automatically makes life clearer for a superintendent in a school system. That's only true in theory. In the real world, the vast majority of commercial and industrial customers do not understand how these rates work and have very little ability to model costing with clarity. The rate book is written in technical language. The terms and conditions are dense, and most operators do not have the time or, honestly, the desire to become experts in reading tariffs. So, while a planner might say time of use is a tool to help customers make better operational decisions, that is not how it shows up on the plant floor. There's a massive gap between the people who are abnormally interested in the grid and love drafting these things and the people who are trying to keep a plastics line running or keep classrooms comfortable. That is what I call the energy system gap. Now let's talk about the environmental story for a moment. Some sources like to connect lower grid strain with lower emissions and cleaner air. There's an implied story that if you move demand around in time, you somehow change environmental impact. But here's the issue: demand timing does not correlate directly to emissions. Kilowatt hour consumption correlates to emissions. Time of use incentives, even when they work, change when you use power, not how many kilowatt hours you use over the month. There's nothing inherent in time of use that reduces total kilowatt hour consumption. It just encourages you to burn those kilowatt hours at a different time. So the environmental claims are, at best, thin for most commercial and industrial customers. If your board or investors want sustainability goals, that's fine. But do not confuse a timing incentive with guaranteed emissions reduction. Let's come back to what you actually care about: your bill and your operations. So, when does time of use clearly help you? It clearly helps operators who either already operate heavily in off peak periods or who can realistically shift meaningful load into those off peak windows. If you run 2 or 3 shifts, or if you have critical processes overnight, you have a much better shot at using time of use well. Same thing if you're a facility with around the clock loads where you can sequence and automate so the highest demand events and the heaviest loads are happening when the tariff says off peak. It also helps when you or your partner deeply understand the rate. You see, a rate is not helpful or unhelpful in and of itself. It becomes helpful when the customer knows the parameters and has the capacity, internally or with a highly capable third party, to design operations and technology around those specific parameters. So, for a manufacturer running multiple shifts who is motivated to invest in automation or storage and who has access to real monitoring and tariff expertise, a time of use demand rate can absolutely be turned into a structural cost saving advantage. But notice the conditions I just described. They're not soft. You need 3 things. First, real qualification. Across Indiana, time of use is not simply available to everyone who wants it. There are prerequisite qualifications. Certain general service rates have no time of use options at all. Others have limited off peak provisions or only offer it at industrial levels. So, step one is, do you even qualify for a time of use style demand rate in your territory? Second, You need flexibility. You must be able to change behavior or operations in line with the incentives and penalties in that rate specifically. If you're a plant that can only run a single day shift and your heaviest loads must run between early morning and late afternoon, then the question, can we shift to off peak, is already answered. Third, you need visibility. Energy monitoring is essential when you're working with any demand based strategy, but especially with time of use. You need to see demand over time. That is how you get to a load profile. And you need that load profile visually compared against the peak and off peak windows in your rate specifically. Without those three, time of use is just another complicated rate that can easily cost you more money, not less. So let me say one more thing on visibility because this is where many projects go sideways. As I said earlier, these should really be called time of use demand rates. The incentives and penalties are often applied to demand, not just energy broadly. Utilities will bill you on the highest demand peak in the period, and they will treat that differently depending on whether it happens in a defined peak or off peak window. That means you cannot say you're working a time of use strategy if you do not have a way to see your real demand behavior over the full billing period in the context of those exact windows as they're specified in your exact rate. And this is where solar gets misrepresented quite a lot. You'll see proposals that say, our solar project will reduce your peak demand, especially if the peak period lines up with sunny hours. It's true that on a clear day, solar can reduce what the grid sees as your demand during that moment. But utilities bill on the highest peak in the whole billing period. And it only takes one cloudy day or one day where operations look different for that solar effect to vanish from the billing math. So, over 12 billing periods in a year, the idea that solar alone will reliably reduce billable demand in the peak windows is not a reality. The only way solar reliably mitigates demand during peak times is when it's paired with storage and a smart control solution that's explicitly designed to shave those demand events according to that specific tariff. That is more involved than most glossy proposals make it sound. Now, I want to talk about when time of use hurts or at least disappoints. First, it does not usually lock you in by itself. In my experience, where a time of use rate exists, there are also rates without those dynamics. But most utilities do limit how often you can change rates. In many territories, you cannot change your rate more than once every 12 months. So when you pick a time of use rate, the lock in is not coming from the peak and off peak concept. It's coming from the general rules that say you live with this choice for one calendar year. If you switch into a time of use rate without a clear plan and without visibility, you can find yourself riding out an expensive experiment. Second, time of use hurts when it's treated as free money for businesses that cannot or will not change operations. A plant that runs one shift in the middle of a defined peak window, that has no appetite to move production or invest in automation, is not going to magically benefit because the utility offers a time of use demand rate. In that case, you have opted in to more complicated billing with limited or no upside. Third, time of use hurts when vendors get sloppy. Abstraction or approximation is never okay with time of use. Peak and off peak hours are specific. They're written in the tariff. They're not forgiving. If a vendor is selling you storage, control systems, or anything else that's supposed to work with your time of use rate, they must be able to operate at the level of detail that the tariff demands. So let me give you the questions you can use to smoke out nonsense. First, what are the peak and off peak times for my utility provider? And then for my specific rate. Not, oh, it usually is daytime versus nighttime. I mean, on this rate, Monday through Friday. No, it must be on this rate, Monday through Friday. Peak is from this clock time to this clock time. Off-peak is from this time to this time, and here is what weekends and holidays look like. We've got to cover the whole calendar and the entire clock. Second question, which days do those times apply to? Again, not generalities. The vendor should be able to say, beyond a shadow of a doubt, on weekends, it's these hours. Saturdays and Sundays are treated like this. Holidays are treated like that. All for your specific rate. Not another rate, not a rate from another state, not a rate that a different customer has, but your rate. The third question, what is the exact incentive? Is the benefit a 30% difference between peak and off peak? 40%? Is it only applied to demand? Is it applied to energy and demand? Which line items on the bill obey this time of use structure or are impacted by it? They should be able to tell you clearly this is how much more you pay in the peak window per kilowatt or per kilowatt hour. And this is how much less you pay in off peak. And these are the exact data points in the tariff that define it. And here's where you see that on your exact bill. Fourth question, show me my tariff and point to where your project lines up. You should be able to say, pull up my specific tariff. Show me on the page where the peak and off-peak windows are defined. Show me the section where the incentive is described and show me where you have taken those numbers into account in your model. And if they cannot do that, they are not qualified to design a time of use anchored project for your facility. All right, let's talk about what you can actually do this week without buying anything. Step 1, get your rate schedule and tariff in front of you. If you do not know which rate you're on, or you've never seen the full tariff sheet, find it. This might mean pulling it from the utility website, calling your account rep, or asking whoever internally handles bills. You want the document that defines your rate, including peak and off-peak rules, if they exist. Step 2, get your load profile, or at least interval data so you can create a load profile. If you have an energy monitoring system already installed, use it. If you do not, see if your utility provides interval data downloads. Many do. Even a basic graph of demand over time for a month, when overlaid against the peak and off-peak windows, will tell you whether your operation is naturally an off-peak candidate or not. Step 3, ask yourself honestly questions about your operational flexibility. How do your shifts run? Are there any processes that can move by an hour or two without destroying your critical path? And can you do so reliably if you chose to? Do you have loads like refrigeration or storage where you can pre-cool or sequence compressors? Or are you stuck with a rigid production pattern that lines up with defined peak windows? Your capacity to change behavior is the real limiter on whether time of use can be turned into savings. Step 4, if you're already on a time of use rate, do a sanity check. Overlay your demand profile with the tariff windows. Are your highest demand events happening in peak periods or off-peak periods? If they're still in peak, your theoretical time of use savings are probably not material. You may even be paying a premium. Step 5, if you're in a deregulated market and you're hearing about block plus index plans or open market structures, recognize the following. In deregulated markets, there are additional products and dynamics. What does not change is this: commercial and industrial consumers are almost always undereducated and under-equipped to really understand what they're buying unless someone takes the time to translate it, and that person must be reliable. So if you're being pitched complex structures tied to time of use concepts in those markets, apply the same discipline. Ask for specifics. Ask to see how it plays out against your actual usage instead of a vague or generalized promise. Let me give you my personal take to bring this whole thing home. Time of use rates can be advantageous, but that advantage is conditional. In Indiana, we see that clearly. Some general service rates do not offer time of use at all. Some industrial rates have limited off-peak incentives. There are hurdles and there are prerequisites. So before we even get to projects, there is a gating question. Can we even be on this rate? And if we can, what are the rules for entering or leaving it? In many territories, if you switch in, you live with that decision for 12 months before you can change again. And that is not something to treat casually. The second piece is the split identity that shows up in the writing. On the one hand, time of use is presented as an incentive, an operational playbook of sorts. We will price power differently so you will change behavior. On the other hand, those same sources say if you already operate in off peak windows, you'll benefit from time of use a lot. Those are two different customers. One already has operations that fit the desired pattern and is being rewarded for that. The other would have to undertake real operational change to fit the pattern. So when you read these articles, they tend to talk as if both are obvious wins, when in reality, for many plants, operating overnight is just not on the table. The third piece is the knowledge gap. I've spent a lot of time reading rate books, sitting with utilities, and modeling tariffs. I still find them tedious. Now, imagine a superintendent at a school system or a plant manager at a plastics facility trying to do that after working all day. It's not going to happen. The grid planners, the engineers, the people who write about the market are not representative of you. They're excited about the mechanisms. Most operators are not. And yet, operators are the one who live with the bill and the consequences of the decisions. So, my stance is this: time of use and other tariff opportunities are wildly underutilized, not because customers are lazy, but because the system is inaccessible. There's a huge opportunity for customer centric consultants and technology providers to become a real translation layer between the rate book and your operation. So let's recap this in very simple terms. So, when is time of use likely a winner? When you can qualify for the rate, when you run 2 or 3 shifts or have substantial off peak operations, when you have the ability and willingness to change operational patterns based on the tariff rules, when you have real energy monitoring and can see your demand profile, when you or a trusted partner can map that profile against exact peak and off peak windows and use that to design projects. And when is time of use a poor fit? When your facility is locked into daytime operations and cannot move meaningful load. When you have no monitoring and no appetite to invest in it. When you're relying on solar alone to handle demand and peak windows, when you're switching rates without understanding that you may be stuck there for a year, and when the only plan you have is a vendor deck with vague generalities instead of tariff level specificity. If I had to pick one underlying concept to take away from this, it's this: time of use is about the relationship between your demand pattern over time and your very specific tariff windows. Until you can see that relationship, you are guessing. Look, I don't run your plant. That's your job. My job is to translate all of this mess and give you questions and leverage you're not getting from a vendor sales deck or from your rate book. So here are a few questions you can take into the morning huddle with finance, operations, facilities, or your energy partner. First, what exact rate are we on today? And does that rate even have time of use or peak versus off peak provisions? Second, have we ever pulled our demand profile for a full month and compared our highest demand events against a defined peak and off peak window in that tariff? Third, if we switched to a time of use demand rate or stayed on the one we have, what real flexibility do we have to move load into the off peak periods the tariff defines? Fourth, any vendor talking about time of use with us, can they show us in our tariff the precise peak and off peak periods and the exact financial benefit between them, and then show how their project uses that mechanism? If you just start with those questions, you will be ahead of the vast majority of the market. Now, let me talk to two groups who are listening. If you found this episode useful, but you're not currently making a specific time of use related decision, think of one other operator or leader in your world who's dealing with strange bills or confusing rate options and share this episode with them. That's how slowly we close the energy system gap. If you're in the second group where this is not theoretical and you're actually considering a time of use decision in the next 3 to 6 months, I'm going to make you an offer. If you're an Indiana commercial or industrial operator on one of the Indiana utilities and you have a serious electric bill, and you're being pitched a time of use demand rate or storage or controls that depend on time of use, or you're thinking about maybe switching rates, we have an energy decision blueprint built for this exact situation. And here is what it looks like. First, we start with a short discovery and fit call. The goal is to make sure there's enough upside around this time of use decision and enough data to make it worth going deeper. If there is, we do a data pull and a survey, and we gather the last 12 months of bills, interval data where it's available, and the context on your shifts, major loads, and any constraints you may be dealing with. Third, we schedule a 60 to 90-minute working session. In that session, I sit down with you, and when it's appropriate, I bring in one of our rate experts. We plug your data into the same rate engine and tools we use for existing customers. We walk through what your bill is actually doing today under your current rate, how your demand is behaving inside the defined windows, and how the main time of use related options you're considering would actually behave on your tariff. We're not guessing, we're using your data and your rate. Fourth, we give you a simple, board ready summary, 1 or 2 pages. It covers your current situation for this time of use decision, the realistic range of outcomes if you implement the change or do nothing, and under what conditions I see a real economic opportunity. For qualified accounts, that energy decision blueprint is free. There are only 2 outcomes I consider acceptable. If there's a real play, we'll show you what it looks like. If there's not, we'll tell that to you straight so you can stop burning time and energy chasing a concept that will never actually improve your cost structure or reliability. If you want that for a time of use decision you're facing, go to tacticalenergygroup.com and look for Energy Decision Blueprint, or use the link in the description to get in touch with us about a blueprint for time of use. Thanks for listening to the TEG podcast. If this helped, send it to another operator who's dealing with the same headache and visit www.tacticalenergygroup.com to get more practical tools for your facilities.